Добрый вечер, коллеги. Мы сегодня расскажем ровно
Good evening. We'll talk about what is written in the presentation,
практически бесконечным
SSO in the building of Keycloaks.
Так, я забыл оплатить. С бесконечным количеством кейклоков. И мы, это я, Бутенко Алексей, лидер продукта платформы MSE.
Infinite number of Keycloaks. And Valeria Yepifanova, our leading developer, so many ideas she had, and we managed to realize. The first question is why and what we need to move to these questions. Open source, it has its own advantages and disadvantages, and of course in enterprise it's all is multiplied, and it's more difficult to perceive that. In our case, one big Russian organization, a huge number of employees, and they want to use clear interfaces that are written in Keycloaks, and they develop a lot of services, and somehow all of them supposed to be deployed and separated. So, and of course, the questions of zoning, deployment, and many other things that you can bump into in the enterprise. So, Keycloak as open source is good. Those of you who came across it, and probably you saw the problems of caching and the cache itself that they use there. Maybe it's the lack of enterprise-ready solutions and some quality deployment. In the case of enterprise, it's also the possibility to deploy open source in several data centers and how to configure this structure, so to speak. So what to do with all of it, with all these things? Because on the one hand, you want to use those benefits and perks that open source gives you, but on the other hand, everybody knows that you can't do it right at the first time, but globally we can do something. 5 points. And then we will focus on the first two. The first one is scalability and shareability. So that's how to build in this landscape, how to build it, solving the problem with cache, with deployment, and imitations of micro services. And here you need to think about policies, regulations, many other things, monitoring. And of course, there is a very important point. It's pretty large infrastructure, so that's the point of scalability of data. And replication. Well, the key point here is that in our case, the best approach is replication. So if you don't know replication, there is physical replication, where we copy from server to server some blocks of data. We just move files with logical replication, when we just ensure the possibility of copying some elements of tables that are identified. And the third one, the most complex case, when application level replication. And again, everybody understands it's full control over the replication process, possibility to adapt any component of this replication to the business specifics, and of course the disadvantages of this, flaws of it. So the potential bicycle invention, as you know, and from this coordination issues, processes, and many other things.
Преимущества, кажется, в определенных случаях перевешивают.
And in many cases, advantages, they actually overweigh disadvantages, and side effects would be this is the appearance of read-only replications, only at the authentications function and providing some data. And after that, with The big landscape was separated in control plane and house plane. It's clear that's control plane and house plane, controlling and the functioning. So, and after that, was separation of that is part of this it's read-write threads, and as a result of it, in this approach, in multi-data center, when you use some smart balancers, you can balance the traffic depending on the customer and depending on other parameters of the server that you service. How physically this applicable replication looks, this app-level replication. So we put together vectors of changes that we send to the database, the inserts, updates, we save them up to the level of lines. We send it to the system of applicable replication control, and in the replicas, you use the data and different copies of this that are working with the data. But that's not the only task of it. That when we have so many replicas in this case, it have the landscape. So we users, we could run through all these replicas without creating any problems. And here's the second part. This is SSO. And I would like to ask Valeria to continue. Thank you. Hello, we'll talk about SSO and what it is and how it works and what's wrong with it, and do we need to do anything with it? Do we need to improve it? So what is SSO? So this is a method of single entry. When the user gets in using the password and login, so it's 1, 2, 3 app. So this is how it works. If you look in ADC, so we have user in first domain using any authentication factor. So the server authentication checks that everything is good, generating a token or a cookie, and after that, sometime later, our user goes to the second domain. This is a green rectangle, and because it's SSO, they don't need to key their credentials again. They just get in. So the box SSO, we can go between clients of one realm, and it's important because if you remember what Alexei said a bit before, when you're building a scalable solution, we have replicas, and we need the users to be able to walk around them, different instances, different realms, and you can do it at the level of ATP. And there are some difficulties here. This is because of there's delays of redirects. At least we have 2. If the structure is more complex, there can be dozens and hundreds. Another thing is the large size of the token. This is all the excessive data, all the claims, the roles and attributes, and if you enrich it with your own claims, they're going to be even more. So, and in this code, you can't customize it for a particular ODC client. So whatever flow you have, that's going to be used for all the clients that you use to get to this through this provider. So what happened with the token, depending on what SSO and what fabric, so we decided to use English to use it more succinctly, so that you can create custom token with a minimum of fields that you need, and the key in this can be a session identifier or ID of the user. And using this, you get your SSO. When you can PTL, it can be additional cookie that will be used in expire. What will give us as minimum, we can look and expired, everything is gone there, so you don't even need to touch the token. So, issue filtering, we need to filter our issues to prevent token substitution. Simple solution, whitelist. In whitelist, you put the issues that you trust, and this is how you filter. And don't forget to to code your token, and if you code it, then what mechanism you're going to use to keep it and to encrypt it. So with SSO in one replication, you get an opportunity to horizontal and vertical scalability. IDP tenancy, we assumed that users can go to different instances, different realms, and not to worry that at some time it's going to be inconvenient, too complex, because the number of IDPs can grow. And when you improve in SSO, you can have a flexible setup for a flow depending on your needs. So if we put it in the scheme, this is what we have. You have the two Keycloaks. It goes to first Keycloak, and they can use it any factor. At this point, cookies are generated, and then they decide to go to Keycloak second, and after the first entry, they had cookie. It triggers a number of checks. When all the checks are passed, the last arrow tells us that the user is authenticated in Keycloak 2. From one instance, they got to the other, and they don't need to key the credentials the second time. So, and another important part, and I throw it back at Alexei. So using these approaches, we managed to build many instances, and it's not the only goal we had. Don't forget the Keycloak itself. It may be solid, but it's not quite ready to modern solutions like Kuber. You can use some YAML programming, and you can come up with some scalable construct. You can find some routes and pods for particular cases, for ATP and many other. And again, this task depends on the needs and the infrastructure and limitations that you have in your company. But nevertheless, so it increases the security of the service and makes it a microservice. So the second goal is more sort of massive in terms of the effort. Keycloak is open source. It's based on known products and the famous cache image spam, and this cache can be replaced with any other, and just add a little bit to the kernel. And don't forget about monitoring and other diagnostic procedures that will help you to understand in this branched out network of Keycloak what's actually happening. Summing up, so what you have as a result if you do it? Globally, you have a big scheme, and it can be used to very large organizations. As we said in the beginning, so we have a separate entity with control plane, and here it's spread in 3 data centers, and it gives you quite high accessibility of the service in different configurations, in different network zones, or depending on the how critical this system is and how critical it is for the business. You can look at it offline if you need to. I'm sure that you'll have questions. And if you have questions, so please write to us, to Telegram. I'll try to answer. So there will be a small questionnaire, so please leave your comments, maybe some feedback, and it would be nice to learn from you. So I think that's it. Thank you very much.
Спасибо большое за доклад.
Thank you for your presentation. As I see we have questions, so let's begin. Alex, hello. In Infosystem Jet, we realized many SSO projects. First question: why did you like Ethernet Spammer in distributed cache and you decided to do your own? We don't say we make our own cache. There is a problem with infinite span itself. In fact, it's not quite stable when it's loaded significantly, especially if it is spread, like on the picture, if it's spread into many examples, into many copies. So we spam with several servers. So we try to do it in many ways, in between cells, and certain problems flagged up. What big load you're talking about? 1,000 authentications per second. Recently we did NT as part of distributed cache in Yandex Cloud, and we didn't have any problem. See here two answers. At some point you may have those problems. Sorry for putting it flat, but infinite spam can't synchronize nodes and have like cascading failures for the new sessions. So the key, of course, it's not just the number of authentications, it's the number of sessions and everything that's happening around it. So if you have many roles and some attributes and everything that gets into cache, so it blows up cache and cache falls apart under the load, and you have like cascading failures.
Добрый день, спасибо за доклад. Хотел бы спросить.
Thank you very much for your presentation. I saw on the slide you said that Keycloak, you can change names for all clients. So if all clients have one single role, and in each application you can set up, you can't control and manage theoretically of the flow if you want to bring dozens of different realms compliance. Probably we can tell you offline in more detail. The point is that default constructions, they are limited in terms of configuration. When you say client, you mean applications, right? Exactly. Thank you.